Okay, so this is us, Python and other technologies for data analysis. I'm excited. I think you guys, there seems to be a lot of interest in learning Python. You guys have the sense of like, Python's pretty great, and it is. I love R and I love Python. Those are like my two languages. And but anyway, let me pull up the syllabus. And I just want to point everybody, and especially those who didn't get into the class. You know, you can teach yourself a lot of this stuff. Okay, there's a lot of stuff. These two textbooks, Python for Data Analysis and the Python Data Science Handbook, these are available to you free, okay, for being a UCLA student, okay? UCLA pays for, well, I guess technically part of your tuition goes to support the UCLA library, and the UCLA library has subscriptions to Safari Books Online, which gives you access to these books. If you try to buy these at the bookstore, they're like $60 each, okay? Maybe they're like cheaper on Amazon, 30 something dollars on Amazon. But they're free here, okay? The only thing is you have to read it in your browser while you're connected to the UCLA network, okay? So if you're at home, you have to VPN, connect via the VPN, and then you can read these textbooks, okay? What's that? Okay. All right. So those are, and so if you didn't get into the class, you can look at these books, and we're just going to be using stuff out of there and data camp. Okay. So the other big thing, and this I can't do anything about for you guys, but data camp is giving us free subscriptions for everyone enrolled in the class. Okay, so that's a very nice thing that Data Camp does. Is they sponsor, I guess, classes and stuff, and so they are sponsoring our class. And so if you're enrolled in the class, you have to actually be enrolled, not just auditing. You get a Data Camp subscription. I think Data Camp's a great tool and resource, and so. You know, if you're auditing, you have to pay for the subscription yourself out of pocket. I think it's $30 a month, which is, you know, it feels kind of expensive, especially if you're a student. But I think it's a very great resource, a very great site, and I would say it's worth the cost of the subscription if you use it, right? Just like a gym membership is worth it if you use it, okay? But, you know, just like gym memberships, they try to get you to sign up for a year all at once because they know you're going to be excited about it in the beginning, and then after month 3, you don't use it as much. And I think probably similar stuff happens with Data Camp. But if you're paying every month, you know, even though it's a little bit more expensive, you're probably more likely to use it. So anyway, I will send invitations to everybody's email address that's on file in the roster, right? So UCLA has your email address. So I'm going to send invitations to Data Camp using that of the students who are enrolled. You'll sign up. I'll send them out after class today. You'll sign up. You'll have a free, I think, 6-month subscription. So, you know, our quarter ends in 3 months, and you'll still have 3 months after that, which is really nice. And you can learn a lot of stuff. All of our homework is going to be done on Data Camp, and I've tried to. So this is just a disclaimer. This is the second time ever this class is offered, right? Spring quarter was the first time ever, and I had fun teaching it, but I also there were a lot of mistakes that were made, right? So I'm changing things, and I'm trying to improve things. I'm not going to say it's going to be perfect this time either, all right? So we'll try it out, okay? these are a bunch of courses. We're going to go through all of these courses on Data Camp, and you're going to do your homework there. Let me get signed in here. So I'm going to send it. You'll sign in, and it should get you enrolled into the class 2018 Fall Stats 131, and the assignments are all listed here. Okay. But basically, what you're going to do, and you sort by due date, okay? And the very first one we're going to do is going to cover Git, okay? And I have completed the course, but let's see. And I have 96,000 XP, whatever that means, right? They game, you know. Studies have been shown that if you gamify learning stuff, people are more likely to complete things. So anyway, you get points for any whatever. Okay. So anyway, your first assignment is going to be Git. This is going to be, I think, due next Wednesday, October 3rd. All right. And I've tried to pace these out. So the courses, I don't know where they went. The courses are made up of chapters. And basically, I've pasted out so that if you do one chapter every single day, 6 days a week, you will stay up to date with all of the homework, okay? And all the homework due dates are kind of paced out accordingly. In the spring, I just said, make sure you do all of these things and it's due at the end of the quarter. That was a big mistake because, you know, week 7 came by and like half of the students had only finished like 2 courses and they should have had done like 8 of them. And so it was a little bit of a disaster there. So now I've like had to do a little bit of micromanaging in that like we set all of these deadlines like spaced out on these days. So basically you do one chapter every single day, 6 days a week, you'll stay up to date with the homework, okay? The chapters can take anywhere from 30 minutes to an hour to complete, okay? And it should be good. I think Data Camp's a great resource. You know, depending on how far you put off, like if you've procrastinated, which, you know, I'm like the master of procrastination. But, you know, depending on what has happened, it might be tempting to just like try to rush through the course as fast as possible, okay? And I would discourage that, all right? I would encourage you to kind of take your time, do the thing in Data Camp, and then and see if you can do similar stuff on your own computer, separate from Data Camp, okay? And try to learn that way, okay? Just like everything else in life, you know, you'll get better by practicing, okay? And you know, if I don't know if you did any sports in high school or whatever, but you know, you have like designated practice, and then after the season is over, maybe you did nothing, or maybe you worked hard, and you know, basically the people who did stuff beyond what was required are the ones who get better, right? And so same thing with coding. Coding's just like anything else in life. The more time you spend working on it, the better you're going to get. So anyway, you know, work through the chapters. There's good learning there. Take notes if you want to, and then I would say try to you know, do stuff. So anyway, this is the homework calendar. I like to be flexible with my homework assignment deadlines and allow for grace and stuff like that. But unfortunately, Data Camp does not have my teaching philosophy regarding deadlines. And so they only allow for homework assignments to be classified as on time, completed late, or not completed, okay? And so, so the way, so I have all of the deadlines programmed in here. If you complete it by the deadline, you will fall in the green box. And if you are in the green box, you'll get 100% for that homework assignment. If you fall in the yellow box, you'll get 70 points, all right? And then if you're in the red box, you're gonna get 0, okay? Because red means you didn't finish the assignment. So please make sure you work through the assignment and you finish them, okay? There's nothing stopping you from like binging on data camp and finishing all of your assignments in a couple weekends if you want. It's probably not the best strategy, but you know, if you want to like get ahead, you're welcome to do that. But you don't have to, okay? And then and your data camp subscription unlocks everything in data camp. So like I've assigned 13 of the data camp courses to our class, but there's like 100 something courses. It unlocks everything. And so even after the course ends, you get another 3 months. And if you say like, I want to learn, you know, whatever else, you're welcome to do that, right? You want to get better at R, there's a lot of stuff on R as well. And so that's really nice of data camp. So I hope they continue this educational sponsorship stuff, because I don't know what I'll do if they take that away. So anyway, so you know, make sure you follow this the homework listing. Okay, I'm not going to homework assignments don't show up in like the weekly modules and stuff like that. Okay, they do show up in the grade book, and we're just going to like manually import the grades from data camp into our CCLE notebook and stuff. Okay, any questions on that? All right, so I'll send out invitations later today. You'll accept those, and that should give you a free subscription to data camp. Okay, what do I want to say before we get started? Is everyone a senior? Who's not a senior? Okay, well, welcome. All right, so I imagine, and so then most of you are planning on graduating this year, right? Barring any unforeseen circumstances or things like that. And then I imagine many of you will want to, after you graduate, will either want to work or go to graduate school, right? And if you want to go to grad school, you know, probably the strategies of what you're going to do this year is a little bit different than if you're going to work. But there's a lot of things that are going to be common. And that is, you want to, I think an important thing is you want to be able to demonstrate your abilities and your, you want to be able to demonstrate your abilities, not just say, I finished my degree and I took these classes, okay? Because everyone in this class, at the end of the class, well, assuming you don't drop, everyone who sticks it out will at the end be able to say, I took a course in Python, okay? But that's also lots of other people out there, right? And then every time I go on YouTube, apparently they know they have targeted advertising and they're like, oh, do you want to learn about machine learning? Why don't you try this course on, you know, Udemy or whatever, okay? And so there's lots of people who are out there learning things. I would say you want to be able to distinguish yourself, and rather than just say, I took a class, you want to be able to say, I can do this, and let me show you, this is what I've done, okay? And being able to say, this is what I've done is a lot more powerful than saying, I took a class. Okay, I took a class in Python versus this is what I've done in Python. Those are big things. And if I'm an employer, if I'm looking to select somebody, I want to see the people who've done stuff versus the people who said I took a class or I learned something. Okay, and I think one of the biggest places where you can demonstrate this is on GitHub. Okay, GitHub has kind of become just like the place where people post their code and stuff, okay? And so in this class, the very first week we're going to do is we're going to learn how to use Git put things on GitHub. And I encourage you to put stuff on GitHub. Now, please don't put, well, in this class I don't have separate assignments. Like, please don't take like your homework assignments from other classes and put those on GitHub. That's not impressive or helpful. You want to do like kind of original things and put them on GitHub there. Okay, and then once you've done stuff and you can demonstrate your thinking and whatnot, and you put that on GitHub, then I think you'll be a much more attractive candidate. And so when students come and talk to me about, what should I be doing, I would say one of the first things I ask is, do you have a GitHub? What do you have on your GitHub? Okay, and this is unrelated to the course directly, but just related in general to making yourself an attractive candidate, whether that's for school or for employment, is you want to put something on the GitHub, and the kind of things that you want to publish out there are probably, if you're going for a data science type job, is to show your data science or data analysis abilities. And so you will want to produce and publish a report, and you can host that on GitHub. And if you're not sure what I'm talking about, you can go to Kaggle. Kaggle is it started off doing data science competitions, okay, but now it's kind of expanded into this little data science hub-ish thing. And they have lots of data sets available, and you can download these things and do some kind of analysis. The kind of things that I think you should try to publish on your GitHub is go over to this page called the kernel. I'm not sure why they call these kernels, but go over to kernels, and then I would suggest sort by votes, okay? Because anybody can publish their thing onto Kaggle, and so there's like a lot of good stuff, but there's a lot of like mediocre stuff as well. And so when you sort by votes, it brings the good stuff to the top, okay? And you can kind of see, these are some stuff that people have done. All right, this is data science tutorial for beginners. It's still really good, okay? Don't let this thing about beginners turn you off. Just and what you have is, and I think this is kind of a good form, is that you kind of you do a lot of maybe over explanation in your report, because it kind of explains the way you are thinking about your data. So anyway, you explain all of this stuff, you explain the data, and then you put in the code that you've done, and you publish this. Okay, this is done on Kaggle, but you can kind of put these things on GitHub as well. Okay. So anyway, so our first week we're going to learn Git and GitHub. All right. So you're going to go on Data Camp and do the Git assignment. I don't know how to. Okay. I can't actually get there, but you'll go on Data Camp and do the Git assignment. Now the assignment on Data Camp focuses on the usage of Git, mostly I would say on your local computer. All right, and so what is Git? Git is a version control system. It's also a system to allow kind of merges and things like that. But the idea is, when you might be working on some kind of assignment, right? You can imagine writing a paper, and then and you write, okay, you start off with paper, and then you have it like paper draft .docx for if you're working on a Word document, right? And then you make some revisions, and you say like, okay, paper final version, okay? And then you add an appendix, and then you rename it, paper final version with appendix. and then you have to say like Papal Final Version 2 with appendix or something like that. And you keep building, you have like this, if you keep renaming the files, you end up having like 5 files that are of the same thing, okay? What Git does is it keeps track of all of the changes, okay? So rather than having to make multiple versions of the paper so you can kind of compare past versions and current versions, Git keeps track of everything for you. And you can go into the kind of the history, the hash history, and restore older versions of the file if you want, okay? And so the way Git works is you set up what's called a repository, okay? A repository is basically a folder or a directory in your computer that is designated and tells Git, please keep track of everything in this folder, okay? But when you make it a folder monitored by Git, it becomes a repository, okay? And so you tell Git, please keep track of everything in this folder, and it does. Everything, files appear, files get deleted. It keeps track of everything. It keeps track of the history. But it's all histories that you've got to, you kind of have to explicitly say, these are the changes I need to commit to the, commit to the repository, okay? So, all right, so let's talk about all of this stuff. I have a bunch of links here, all right? One is you're gonna download Git, all right? You just go to the Git website here and you just download it for Windows or for your Mac, okay? You're gonna wanna create a GitHub account, all right? And, so this is, I'm already logged in there. And then here's a bunch of guides on kind of how to do stuff here, okay? So we're gonna just first start off using Git. And so let me go into just kind of this folder here. And let me delete this. Okay, so when you install Git, if you're on a Windows PC, you might install a program called Git Bash. If you're on Mac, you can just open your kind of terminal and Git will be installed there. But anyway, Git Bash just basically looks like this kind of command prompt here, okay? And you're gonna type in your commands into Git Bash to get it to do stuff that you want to do, okay? So the first things you gotta do is you gotta get into your directory, okay? So CD means change directory, and so I'm gonna go to OneDrive, and it's my teaching folder, and I've got a folder for 131, okay? In I don't know, will ls work? ls is usually, list off what's inside your directory, okay? And this is what I have. And so I'm going to, we want to create a new repository, let's say for this class. So I'm going to call it 2018 Fall Stats 131, okay? And these are all detailed in some of these handouts and also in your thing here, okay? So actually, what I'll do is I'm gonna create a repository in on GitHub. Okay, so here I'm logged into my GitHub account. Okay, and these are, I can go to this is kind of my page, and I have 4 repositories. This was my Spring repository, and I think what we're going to do is we're going to make a new repository. Okay, and so this is going to be a folder on my GitHub account that we're going to create for this class. Okay, and so I'll call this 2018 Fall stats131. Okay, and so this becomes a repository. Now, all of the repositories you make on GitHub are going to be public unless you purchase a premium account. Okay, I don't have a premium account, so it says if I want to make a private repository, it's asking me for my credit card information. All right, but here I'm just going to make a public GitHub repository. I'll use this to kind of put class notes and stuff like that. You can do things. All right, so this will just be repository for stats131 class at UCLA. All right, so we will do this. Yeah, let's go ahead and initialize this with a README, and I'm going to click Create Repository. So all I'm doing is I'm just going on the website and I'm saying, let's make a repository. Okay, and here we are. This is the repository, all right? And so I want to be able to work on this repository on my home computer, okay? I want to work on it here. You can edit things directly via the web interface here, okay? But that's probably not how we're going to do it. So what I'm going to do is I'm going to click clone or download, right? And I have to copy this, and this is going to create. This is going to be the way I set up my repository down in my computer down here. Okay. In order for this to work, you have to set up SSH keys. Okay. You have to set up SSH keys, and that just allows the GitHub server to communicate to your computer and know that your computer is authorized to make changes to your GitHub repository that's public on the internet. Okay? They don't want just some random person to just start making changes to your files online. Okay? And so to authenticate that, you need to set up an SSH tokens and stuff, and I have all of those instructions here. Okay, so you click this, generating a new SSH key, just follow these directions, and then adding an SSH key to your account. So you'll have to generate an SSH key on your home computer. It's like this long, I don't know, it's like 100 digits or 100 characters long, or it's quite long, and you copy and paste that into your GitHub account. And that, so you just follow these directions directly. Okay, so open git bash, type in this command or just paste this. Okay, and then so that generates the key, and then once you have that, you'll add the SSH key to your account, and you'll go to in GitHub over here under settings. You'll come over here to SSH keys, all right, and you'll add your SSH key here, okay. And so and basically this says, this is the one I've used. This is my Surface Book. This is the key that my computer uses, right? So this is the fingerprint. This is not the actual key. Don't worry, you can't hack in just because you saw that fingerprint there. Well, I don't know, maybe maybe that's a dangerous thing, but anyway. So anyway, you set up your SSH key, and now you can interact with your GitHub account on your local machine. Okay, so anyway, let me go back to that. So this is the repository we've set up, okay? And so here I'm going to, inside my folder, I'm going to type in Git Clone, and paste in the address of this repository, okay, this thing that we've just set up. All right, so it has cloned the repository, okay, and so now if I ask for a directory listing, we now have this thing here, 2018 fall stats 131, so I'll just change into that. 2018 fall, and then as soon as you type enough to identify something, you can hit tab and it will complete the rest of the thing. That's like most things here, okay? And then so now that I hit enter and I'm in 2018 fall stats 131, we see it now shows up this word that says master, okay? And this means when that appears, this means this is the master branch and it's being tracked by Git, okay? The way Git works is that it establishes, let me see if I can just kind of illustrate. All right, I think I've got a picture. The GitHub Flow, okay? This is what's known, this is kind of the branching thing, and there's something called the master, and the master is supposedly, is supposed to be like production-ready stuff, okay? So if you are working on a program with other people, and this is like being published, right? Like R, for example, is an open source project, so there is this current set of code that, you know, if you download and install R, this is the open source code. Okay, that's the master branch. Now, if people want to make changes to R and add things, and you know, they keep updating the versions of R, they create what's called a branch, okay? And this doesn't affect the main file that people are downloading and stuff, or the main source code that exists there, but there's a branch that people work on. They work on improving things, and while they're working on improving things, they might have bugs, they fix the bugs, they do all sorts of stuff. They keep working on that branch until it's working the way they want, okay? And they commit those changes to that branch, and then when they create what's called a pull request, okay? Because if it's you're collaborating, you ask, can we merge these changes back to the master branch, okay? If there's other people, there's discussion about whether or not this is what we want to do. They say okay, and they merge it back into master, right? You know, when you're working by yourself, maybe you don't need to have as much of a branched flow, but the idea of branching, creating branches and working on them is kind of a central idea of Git, in that the master branch is the one that if somebody says, you know, we need to turn in something now, you can say, all right, take the current version that's on master and turn it in. It doesn't have any errors. It's good to go, okay? And then when you want to add changes, you want to add functionality, okay? You do that on a branch, okay? Branches that are not the master, you might expect to not be 100% bug-free. And you work on those until you get them to be, until you've ironed out all the bugs, and then you merge those changes back into the master. So anyway, that's what this says, okay? It says we're on the master branch, all right? And I can just say, all right, what's in here? We've got readme.md. That's readme.markdown. This is what I have right here. And I can open this up in Notepad. All right, and this is the README file here. It just says 20. This is in Markdown. Let me how do I zoom in? All right. Okay. So this is the Markdown file. Okay, so you know, just like Markdown language, you can say like, okay, this is a headline 2, headline level 2. All right. All right. Well, maybe I'll just say instructor Miles Chen. All right, and then we'll say email is Miles Chen at stat.ucla.edu. Okay, so here we go. Readme.md. I clicked and I hit file save. I already hit Control S. Okay, and so that is now updated, right? So on my computer, if I open this up, it has the changes that I've made. Okay. What I need to do is I need to commit the changes to the repository. Okay, if I check what does my Git repository look like, I can ask Git status. Okay, and it will say you are on branch master. Your branch is up to date with origin master. Okay, because it recognizes that we've cloned something from the internet. Okay, when you clone something from the internet, there's something called an origin. Okay, and it says these changes are not staged for commit. It says you've modified the readme.md file, your readme.md markdown file, and so we want to commit these changes. Okay, and so first we have to stage our changes for a commit, and then we commit them. It feels like it's a little bit funny, the sequence, like why don't we just commit the changes? But you have to explicitly say, this is the change I want, and I want to commit this change, okay? And so, for example, I haven't committed any changes yet. I might create a new file, right? So I'm gonna come in here, and I'm gonna say, let's make a new text document, and we'll call this info.txt, and we will say our class meets on Monday, Wednesday, Friday, 3 to 3:50 p.m. Okay, so this is info.txt, and that's in my folder now. Okay, and so if I ask Git status, it's going to say we have a couple things. We've got readme.md, changes have been made there, and they haven't been staged and they haven't been committed. And then a new file has appeared, info.txt has appeared, and this is not even tracked. Okay? So we can do, we can explicitly tell Git, I want you to set up a checkpoint with this change and another kind of checkpoint with this change. Okay? Because on our computer, we don't know which file was created and what changes were made. So I'm going to do git add, and I'm going to say add readme.md. So I do git add. So this change, the change that we've made to the readme file, is staged for commitment. I ask git status, and it says, okay, these changes are ready to be committed, and info.txt is still an untracked file. Okay, so now I'm going to say git commit. All right, and when you commit something, you always have to put in a comment about what change is being committed. All right, so you have to say git commit -m to say, like, this is the message we're going to do, and the message is I'm going to do a modified readme file. Okay, all right, so I've done that. And the change is has been committed to the Git. All right, which doesn't seem impressive. Okay, it just seems like it feels like a lot more work right now. I just want to create files. I just want to save them, and now you're telling me I've got to add commits and I've got to commit them. It feels weird. Okay. If I ask for git status, all right, the readme.md no longer shows up because that is committed to our repository and nothing has been changed. But it says, you know, we also have this untracked file. So I'm going to go ahead and do git add info.txt, and then we're going to go ahead and commit this change as well. And I'm going to just say added info.txt, okay? And then, all right, and if I ask for git status, all right, so that change has been committed, okay? It says nothing to commit working tree clean. Okay, that's great. if I go on GitHub into this thing, we see it doesn't look like anything has changed, all right? Okay, readme.md is still there as the old version. And so what we have to do is we have to synchronize my folder to the folder on GitHub, okay? We have to synchronize our repositories, and that's called pushing the changes. So you have your repository, you stage changes by using git add, then you commit those changes using git commit, okay? And that updates the repository on your computer, and you can roll back all of those things and whatnot if you need to go back to older versions. That's fine. But if you want to synchronize the changes on your local machine to the ones on the server, you have to push those things, okay? And often cases, you can just type in git push and it will work. I think this might kick back an error. No. No, it's done. Okay, so it has pushed. You say push these changes. Sometimes when you push a repository onto GitHub the first time, you have to set some options. I think because we cloned it and then now we're pushing the changes back, it understands the kind of the link between our local folder and the one on GitHub. Okay, so this we've pushed the changes online, and so if I refresh this now we can see the changes have indeed been uploaded, okay, and also the info.txt appears here, okay. Also, you'll notice on here it says we have 3 commits, and so I can roll things back. I can go click this history on the 3 commits, and we can go back and we can see this is when we've modified the readme txt file and when we added the info. So the initial commit, I can click this, and this will pull it back to the old version before I made any changes, okay? And you can kind of go through, browse through each commit. I can click this thing, and this will be the contents of a repository and says this is what you've added. And then if I go through this commit, which is the one we have right now, it says we've added the info.txt. So you can go browse through all of the commits that you've done and see how the kind of the history of what has happened. So you commit these changes and you're basically setting up like freeze frame pictures of what's in that folder, and you can always roll your folder back to where it was when you've made those changes and things like that, okay? So Git's a very powerful tool. There's a lot of stuff. We'll cover it some more next week as well. And please get started on your homework. Again, if you do 1 chapter every day, 6 days a week, you'll stay up to date with all the homework assignments. Okay, we're looking forward to this. We'll see you guys on Monday.